Project Management, Agile Approach. This series of slides is the combined slides of all the individual presentations that have been compiled to date. It's very long, which is why the individual presentations were compiled for those that do not have the time to listen to such a long 155 slide presentation. It is important to understand the rationale for any project approach. So in this case, we're talking about agile projects, and I trust that after seeing the rationale for agile projects, the viewers will have a better idea of why agile projects are required and when they are required, which will be in a later presentation. The rationale for an agile project lies in its ability to enhance flexibility, collaboration and efficiency in project management, particularly in environments characterized by rapid change and uncertainty. The key reasons for adopting Agile are flexibility and adaptability, iterative approach. Agile projects are divided into small manageable iterations or sprints, allowing teams to adjust priorities and requirements as the project evolves. Responsive to change. Agile embraces change, making it easier to adapt to new customer needs, market trends, or technological advancements. Customer-centric focus, continuous feedback, regular interactions with stakeholders ensure the project aligns with customer expectations and delivers value. Incremental delivery, delivering working software or products frequently ensures that customers can see progress and provide timely feedback. Improve collaboration and communication. Cross-functional teams. Agile promotes collaboration among team members with diverse skills, fostering better communication and understanding. Regular stand-ups. Daily stand-up meetings help in identifying issues early and keeping everyone on the same page. Increased transparency and visibility. Frequent updates, regular progress reports and reviews increase transparency, allowing stakeholders to track progress and make informed decisions. Clear prioritization. Agile methods like Scrum use tools such as backlogs and boards to clearly prioritize tasks and track their completion. Higher quality and risk management. Continuous testing. Agile encourages continuous testing and integration, leading to early detection and resolution of defects. Risk mitigation. By delivering in small increments, Agile reduces the risk of project failure and allows for adjustments before significant resources are invested. Enhance team morale and productivity. Empowerment. Teams are given autonomy to make decisions, which boosts morale and accountability. Sustainable pace. Agile promotes a sustainable work pace, reducing burnout and maintaining productivity over time. Focus on delivering value. Value-driven development. Agile prioritizes delivering the highest value features first, ensuring that the most critical needs are met promptly. Customer satisfaction. By continuously delivering valuable increments, Agile projects aim to maximize customer satisfaction. Overall, Agile projects aim to deliver high-quality outcomes in a dynamic environment by fostering a culture of collaboration, adaptability, and continuous improvement. Wrapping this section up, there are very likely further reasons for an Agile project to exist. What are your thoughts? Achieving the various objectives, as highlighted in the previous slides, is not easy, however quite doable provided the correct mix of tools and techniques are applied to achieve the product objectives. Composition of an Agile project. An Agile project typically consists of several key components that ensure flexibility, collaboration, and iterative progress. Here are the primary components. Product backlog, a prioritized list of features, enhancements, bug fixes, and technical tasks, managed by the product owner, continuously updated and refined based on feedback. Sprint, a fixed time period, usually 1 to 4 weeks, during which a set of tasks from the product backlog is completed. The goal is to produce a potentially shippable product increment. Sprint planning, a meeting where the team selects items from the product backlog to work on during the sprint. The team collaborates to define the sprint goal and plan the work needed to achieve it. Daily stand-up or daily scrum, a short daily meeting, usually 15 minutes, where team members discuss what they did yesterday, what they plan to do today, any impediments or blockers they are facing. Sprint review, held at the end of the sprint to demonstrate the work completed to stakeholders, provides an opportunity for feedback and ensures alignment with customer needs. Sprint retrospective, a meeting for the team to reflect on the sprint and discuss what went well, what could be improved, and how to improve in the next sprint. Focuses on continuous improvement. Product owner represents the stakeholders and customers, responsible for managing the product backlog and ensuring the team delivers value. Scrum Master facilitates the Agile process and helps remove impediments. Ensures the team follows Agile principles and practices. Development team, a cross-functional team responsible for delivering the product increment, self-organizing and collaborative. User stories, short, simple descriptions of features or functionalities from the user's perspective. These typically follow the format, as a user, I want feature, so that benefit. Wrap up. In short, the composition of an Agile project is a small, stable, cross-functional, empowered team aligned to a clear product goal, continuously adapting how the project works. Product backlog. The product backlog in an Agile project is a dynamic, prioritized list of all the work that needs to be done to deliver a product. The key components of a product backlog are user stories, short, simple descriptions of a feature or functionality from the end user's perspective, typically following the format. As a user, I want feature, so that benefit. Epics, large, high-level user stories that are too big to be completed in a single sprint, broken down into smaller user stories or tasks over time. Tasks, smaller, detailed pieces of work that make up user stories. Tasks are actionable and often used to track progress within a sprint. Features, specific functionalities that the product must include, can be broken down into user stories and tasks. Bugs, reports of issues or defects in the product that need to be fixed, prioritized based on severity and impact. Technical debt, tasks related to improving the code base, architecture or technical infrastructure, includes refactoring, optimization or updating outdated systems. Improvements, enhancements to existing features or processes, can be based on user feedback, performance analysis or other observations. Spike, research-oriented tasks designed to gather information or answer a question, used to reduce uncertainty or gain better understanding before proceeding with development. Acceptance criteria, conditions that must be met for a user story or task to be considered complete. Ensure that the product meets the desired functionality and quality standards. Prioritization. Items in the backlog are ordered based on their value, urgency and dependencies. This is managed by the product owner to ensure the most important work is done first. Estimates. Effort required to complete each backlog item, often measured in story points or hours, helps in planning and tracking progress. Dependencies. Relationships between backlog items that affect the order in which they can be completed. Helps in managing and coordinating tasks across the team. The product backlog is continuously refined and updated to reflect changes in project scope, priorities and feedback, ensuring it remains a central guide for the development team. Wrap up. The product backlog should be thought through carefully to avoid as much technical debt as possible. By the same token, the product should be delivered as expeditiously as possible. Agile Project Sprint. A sprint in an Agile project is a time-boxed period during which a specific set of work is completed. The following are the key components of a sprint. The sprint goal, a clear, concise objective that defines what the team aims to achieve during the sprint. It provides focus and alignment for the team. Sprint backlog, a subset of the product backlog selected for the sprint. Includes user stories, tasks, and any other work the team commits to completing during the sprint. Sprint planning, a meeting where the team collaborates to decide what work will be done in the sprint. The team defines a sprint goal and creates a sprint backlog. Daily stand-up or daily scrum, a short daily meeting where team members discuss what they did yesterday, what they plan to do today, any impediments or blockers. Sprint retrospective, a meeting for the team to reflect on the sprint and discuss what went well, what didn't, and how to improve in the next sprint. It focuses on continuous improvement of the process and teamwork. Product increment, the sum of all completed product backlog items during the sprint. Should be a usable and potentially shippable product increment. Work items, that is user stories, tasks, or bugs. The specific pieces of work selected for the sprint can include new features, bug fixes, technical tasks, or research, that is spikes. Definition of done, a shared understanding among the team of what it means for a work item to be considered complete. Ensures consistent quality and completion standards. Burn down chart, a visual representation of the work remaining versus time. Helps track progress and predict whether the sprint goal will be achieved. Impediments and blockers, issues or obstacles that could prevent the team from completing their work. Identified and addressed during the daily stand-ups and throughout the sprint. Collaboration and communication. Ongoing communication and collaboration among team members, stakeholders, and the product owner. Essential for adjusting to changes and ensuring alignment with the sprint goal. These components work together to ensure the team delivers valuable, high-quality work within the time-box sprint, fostering continuous improvement and adaptability. Wrap-up. Therefore, a sprint is a short time-box period during which a team plans, builds, tests, and delivers a small, usable product. Agile Project Sprint Planning. Sprint planning is a crucial event in an Agile project that kicks off each sprint. It involves the team coming together to decide what work will be done during the sprint and how it will be accomplished. The key components of sprint planning include sprint goal, definition, a clear, concise objective that the team aims to achieve by the end of the sprint. Purpose, provides focus and direction, guiding the selection of work items from the product backlog. Product backlog review. Definition: a review of the product backlog to select items for the sprint. Purpose: ensures the team understands the prioritized work items and selects those that align with the sprint goal. Selected product backlog items, or sprint backlog. Definition: a subset of the product backlog items chosen for the sprint. Purpose: represents the work the team commits to completing during the sprint. Task breakdown. Definition: breaking down selected product backlog items into smaller manageable tasks. Purpose: helps the team understand the specific work involved and facilitates better estimation and tracking. Effort estimation. Definition: estimating the effort required to complete each task, often using story points, hours, or another metric. Purpose: helps the team gauge the workload and plan accordingly. Capacity planning. Definition: assessing the availability and capacity of team members for the sprint. Purpose: ensures the team has a realistic workload based on available resources and time. Team collaboration and discussion. Definition: collaborative discussions among team members to clarify requirements, dependencies, and potential challenges. Purpose: fosters a shared understanding and collective commitment to the sprint work. Definition of done review. Definition: a review of the team's definition of done to ensure all work items meet the agreed upon standards. Purpose: ensures consistent quality and completion criteria for sprint deliverables. Risk identification and mitigation. Definition: identifying potential risks or impediments that could impact the sprint. Purpose: allows the team to proactively address risks and develop mitigation strategies. Sprint duration and time box. Definition: confirming the duration of the sprint, typically between 1 to 4 weeks. Purpose: establishes the time box within which the team will work to deliver the sprint goal. Commitment to the sprint plan. Definition: the team collectively commits to the sprint plan and the work they have agreed to complete. Purpose: builds accountability and ensures alignment with the sprint goal. Sprint planning sets the stage for the sprint by ensuring the team is aligned, prepared, and committed to delivering valuable work within the time box. Wrap up. This activity is the basis for building the product. The objective of this activity is to ensure work is done efficiently and effectively. Agile Project Daily Stand-Up. The Daily Stand-Up, also known as the Daily Scrum, is a brief daily meeting in an Agile project where the team synchronizes work and discusses progress. The key components of a daily stand-up include time box duration. Definition: the meeting is typically limited to 15 minutes. Purpose: keeps the meeting focused and efficient, ensuring minimal disruption to the team's workday. Regular schedule. Definition: held at the same time and place every working day. Purpose: establishes routine and consistency, making it easier for team members to attend. Team participation. Definition: all team members, including the Scrum Master and Product Owner, participate. Purpose: ensures everyone is aligned and aware of the team's progress, challenges, and plans. 3 key questions. Each team member answers these 3 questions. What did I do yesterday? Purpose: provides a quick update on progress since the last meeting. What will I do today? Purpose: shares the plan for the current day, helping the team understand the work for the day. Are there any impediments or blockers? Purpose: identifies obstacles that might hinder progress to be promptly addressed. Focus on collaboration. Definition: encourages team members to share information, collaborate on solving problems and coordinate efforts. Purpose: fosters teamwork and alignment, ensuring the team works effectively together. Impediments and blockers. Definition: issues or challenges that are raised during the meeting. Purpose: allows the team or Scrum Master to take action to remove obstacles quickly. Progress tracking. Definition: the team uses tools like burn-down charts or task boards to visualize progress. Purpose: helps the team track the completion of tasks and monitor progress toward the sprint goal. Facilitation by Scrum Master. Definition: the Scrum Master facilitates the meeting, ensuring it stays on track and adheres to Agile principles. Purpose: helps maintain focus, ensures participation, and addresses any administrative needs. Transparency and accountability. Definition: team members openly share progress and challenges. Purpose: promotes transparency, builds trust, and holds team members accountable for their commitments. Adaptive planning. Definition: allows the team to adapt plans based on new information or changing circumstances. Purpose: ensures the team remains flexible and responsive to change, aligning with Agile principles. The daily stand-up is a critical component of Agile practice, helping teams stay aligned, communicate effectively, and address issues promptly to maintain momentum throughout the sprint. There is a sprint review in an Agile project, which is a meeting held at the end of each sprint to inspect the work completed and gather feedback from stakeholders. The key components of the sprint review are presentation of completed work. Definition: the development team presents the work completed during the sprint. Purpose: demonstrates the product increment to stakeholders and provides an opportunity to see progress. Product increment. Definition: the sum of all product backlog items completed during the sprint. Purpose: represents the latest version of the product that is potentially shippable and usable. Stakeholder involvement. Definition: stakeholders, including customers, users, and other interested parties, are invited to the sprint review. Purpose: provides a forum for stakeholders to offer feedback, ask questions, and discuss the product's future direction. Product owner's role. Definition: the product owner discusses the product backlog as it stands, including what has been completed and what remains. Purpose: ensures stakeholders are aware of the current state of the product and any changes in priorities or scope. Review of sprint goals. Definition: the team reviews the sprint goal and discusses whether it was achieved. Purpose: provides a measure of success for the sprint and helps assess the effectiveness of the team's efforts. Feedback and discussion. Definition: stakeholders provide feedback on the product increment and discuss any new ideas or changes. Purpose: helps the team gather valuable insights, refine the product backlog, and align the product with stakeholder needs. Adaptation of product backlog. Definition: based on feedback, the product backlog is updated to reflect changes in priorities, new requirements, or adjustments. Purpose: ensures the product backlog remains a living document, evolving based on stakeholder input and market conditions. Inspection of progress. Definition: the team reviews progress toward the overall project goals. Purpose: helps stakeholders understand how the product is evolving and assess whether it is on track to meet long-term objectives. Time box duration. Definition: the sprint review is typically time-boxed to ensure it is concise and focused. Purpose: keeps the meeting efficient and ensures productive use of everyone's time. Collaboration and planning for next steps. Definition: collaborative discussion on next steps, potential changes, and upcoming priorities. Purpose: aligns the team and stakeholders on future work and helps plan the next sprint. The sprint review fosters transparency, collaboration, and continuous improvement by involving stakeholders in the inspection of the product and gathering feedback for future development. A sprint retrospective in an Agile project is a meeting held at the end of a sprint to reflect on the process, identify areas for improvement, and plan actionable steps to enhance team performance. The key components of a sprint retrospective include reflection on the sprint. Definition. The team reflects on the events, processes, and outcomes of the sprint. Purpose. Provides an opportunity to evaluate what went well, what didn't, and how to improve. What went well? Definition. Team members discuss positive aspects of the sprint. Purpose. Reinforces good practices and boosts team morale by acknowledging successes. What didn't go well? Definition. Team members discuss challenges, obstacles, or things that didn't work as expected. Purpose. Identify areas for improvement and encourages open and honest communication. Actionable improvements. Definition. The team identifies specific, actionable steps to address issues and improve processes. Purpose. Ensures continuous improvement by implementing changes in future sprints. Root cause analysis. Definition. Analyzing the underlying causes of issues encountered during the sprint. Purpose. Helps the team understand the root of problems to prevent recurrence and improve processes. Team collaboration and participation. Definition. All team members, including the Scrum Master, actively participate in the retrospective. Purpose. Ensures diverse perspectives are considered and fosters a sense of ownership and commitment to improvements. Facilitation by Scrum Master. Definition. The Scrum Master facilitates the retrospective, guiding the discussion and ensuring focus on constructive outcomes. Purpose. Keeps the meeting on track, encourages participation, and helps the team stay aligned with Agile principles. Improvement plan. Definition. A plan outlining the agreed upon improvements, who will take responsibility, and how progress will be tracked. Purpose. Provides a clear roadmap for implementing changes and tracking effectiveness. Time box duration. Definition. The sprint retrospective is typically time boxed to ensure it is concise and focused. Purpose. Keeps the meeting efficient and ensures productive use of time. Psychological safety. Definition. Creating an environment where team members feel safe to speak openly and honestly without fear of blame or criticism. Purpose. Encourages candid discussions, fosters trust, and promotes a culture of continuous learning and improvement. Tools and techniques. Definition. The use of various tools, techniques, or exercises. For example, start, stop, continue. 5 whys or mad, sad, glad to facilitate the retrospective. Purpose. Help structure the discussion and make the retrospective engaging and productive. The sprint retrospective is a key component of the Agile process, fostering continuous improvement and helping teams become more effective over time by regularly reflecting on and improving their practices. Wrap up. Sprints promote consistent, incremental delivery of high-quality software, enhance team focus, allow for rapid feedback, and enable adaptability to changing requirements. Agile project roles. The product owner plays a crucial role in an Agile project, acting as the bridge between the stakeholders and the development team. The key components of a product owner's responsibilities and attributes include vision and strategy. The product owner defines and communicates the product vision and strategy, ensures the team and stakeholders understand the product's goals and how it aligns with the broader business objectives. Product backlog management. The product owner creates, maintains, and prioritizes the product backlog, ensures the backlog reflects the most valuable and necessary work, guiding the development team's efforts. Prioritization. The product owner prioritizes backlog items based on business value, customer needs, and market demands, ensures the team focuses on delivering the highest value features first. User story definition. The product owner defines user stories, acceptance criteria, and ensures these are clear and actionable. Provides the development team with a clear understanding of what needs to be built and how value will be delivered. Stakeholder collaboration. The product owner interacts with stakeholders, including customers, users, and business leaders, gathers feedback, ensures alignment, and communicates the product's progress and direction. Decision-making authority. The product owner has the authority to make decisions about the product's direction, backlog priorities, and scope, provides clear guidance to the team, and ensures swift decision-making to keep the project moving forward. Customer focus. The product owner maintains a deep understanding of the customer needs, preferences, and feedback, ensures the product delivers value by meeting customer expectations and solving their problems. Acceptance of work. The product owner reviews and accepts or rejects work based on predefined acceptance criteria, ensures that the delivered product meets the required quality and functionality standards. Collaboration with the development team. The product owner works closely with the development team, providing clarification and guidance as needed, ensures the team has a clear understanding of the product requirements and priorities. Adaptability and responsiveness. The product owner adapts the product backlog and priorities based on feedback, market changes, and evolving needs. Ensures the product remains relevant, competitive, and aligned with business goals. Continuous improvement. The product owner actively seeks feedback and looks for ways to improve the product and development process, drives the product's evolution, and ensures ongoing alignment with customer needs and business objectives. Communication and transparency. The product owner communicates product progress, updates, and changes to stakeholders and the development team, ensures all parties are informed, aligned, and have a shared understanding of the product's status and direction. The product owner plays a pivotal role in maximizing the value of the product by managing the backlog, prioritizing work, and ensuring that the development team delivers what the customers and business need. The Scrum Master is a key role in an Agile project, responsible for ensuring the Scrum framework is followed, facilitating collaboration and removing obstacles. The key components of a Scrum Master's responsibilities and attributes are: Facilitator. The Scrum Master facilitates Scrum events, for example, sprint planning, daily stand-ups, sprint review, sprint retrospective. Ensures meetings are productive, time-boxed, and focused on objectives. Servant leader. The Scrum Master serves the team by supporting their needs and helping them achieve their goals. Promotes a collaborative and empowered team environment. Coach and mentor. The Scrum Master coaches the team, product owner, and organization on Agile practices and Scrum principles. Helps the team improve processes, collaboration, and overall effectiveness. Impediment remover. The Scrum Master identifies and removes impediments that hinder the team's progress. Ensures the team can focus on delivering value without unnecessary obstacles. Process authority. The Scrum Master ensures the team follows Scrum practices and helps adapt processes as needed. Maintains the integrity of the Scrum framework and promotes continuous improvement. Team Shield. The Scrum Master protects the team from external disruptions and distractions, allows the team to concentrate on their work and meet sprint goals. Collaboration Facilitator. The Scrum Master fosters collaboration within the team and with stakeholders, enhances communication, coordination, and teamwork. Change Agent. The Scrum Master helps the organization adopt Agile practices and facilitates cultural change, promotes a mindset of continuous improvement and adaptability within the organization. Support for product owner. The Scrum Master assists the product owner in managing the product backlog and ensuring effective communication with the team. Helps align the team's work with the product vision and priorities. Continuous improvement advocate. The Scrum Master encourages the team to reflect on their processes and practices, ensuring a culture of continuous improvement. Drives iterative learning and development within the team. Conflict resolution. The Scrum Master helps resolve conflicts within the team and between team members and stakeholders. Maintains a healthy and collaborative work environment. Measurement and reporting. The Scrum Master helps track progress using metrics, for example, burn down charts, and provides insights to the team and stakeholders. Ensures transparency and helps the team understand their performance and areas for improvement. Agile Advocate. The Scrum Master champions Agile values and principles within the team and the organization, promotes the benefits of Agile practices, and supports the transition to an Agile mindset. The Scrum Master is crucial for fostering an environment where the Scrum framework can thrive, enabling the team to deliver high-quality work while continuously improving their processes and collaboration. The development team in an Agile project is a cross-functional group responsible for delivering potentially shippable product increments at the end of each sprint. The key components of a development team include self-organizing. The team manages their own work and decides how best to accomplish the tasks within the sprint. Empowers the team to take ownership of their work, fostering creativity and accountability. Cross-functional. The team has all the necessary skills and expertise to complete the work. For example, developers, testers, designers. Ensures the team can deliver a complete product increment without depending on external resources. Collaboration and communication. The team collaborates closely with each other, the product owner and stakeholders. Facilitates efficient communication, alignment and problem solving. Commitment to sprint goals. The team commits to delivering the agreed upon sprint goal and backlog items. Focuses the team on achieving specific objectives within the sprint. Continuous improvement. The team regularly reflects on their processes and practices to identify areas for improvement. Drives iterative learning and enhancement of team performance. Shared responsibility. The team collectively owns the quality and success of the product increment, ensures accountability and encourages collaboration in problem solving and quality assurance, delivering potentially shippable increments. The team delivers work that meets the definition of done and can be potentially released to customers, provides value to stakeholders regularly, and enables continuous feedback and improvement. Adaptability. The team is flexible and responsive to changes in priorities, requirements, and feedback. Ensures the team can adapt to evolving business needs and customer demands. Technical excellence. The team focuses on maintaining high standards of technical quality and best practices. Ensures the product is robust, scalable, and maintainable. Size of the team. The development team is typically small, usually 3 to 9 members. Keeps the team manageable, promotes effective communication, and enhances productivity. Continuous delivery of value. The team delivers valuable increments regularly, ensuring continuous feedback and improvement. Provides stakeholders with usable and valuable product updates frequently. Focus on customer needs. The team aligns their work with customer requirements and expectations. Ensures the product delivers real value and meets the needs of its users. The development team is the engine of an Agile project, responsible for transforming ideas and requirements into working, high-quality product increments through collaboration, technical excellence, and a commitment to continuous improvement. Wrap-up. An Agile project has the necessary roles and responsibility to maximize the chances of a successful project. User stories. User stories in an Agile project typically consist of the following components. Title, a short descriptive name that summarizes the story. Description, a concise statement of the requirement, often following the as a user, I want goal, so that reason format. This helps clarify who the user is, what they want to achieve, and why. Acceptance criteria, specific conditions that must be met for the story to be considered complete. These criteria help ensure that the story fulfills the user's needs and provides a basis for testing. Priority, an indication of the story's importance or urgency relative to other stories. This helps a team focus on delivering the most valuable features first. Story points or estimate, an estimation of the effort required to complete the story, often expressed in story points or other units of measure. This helps the team plan and manage workload. Conversation notes, any additional details or context gathered from discussions between the team and stakeholders, which can provide further clarity or guidance. Tasks, a breakdown of the user story into smaller, actionable tasks that team members can work on individually. Assign team members. The team members responsible for completing the task associated with the user story. These components help ensure that user stories are clear, actionable, and aligned with the project goals, facilitating effective communication and collaboration within the Agile team. An increment in an Agile project refers to a tangible, usable outcome that represents a step toward the final product. The components of an increment typically include working software. The most critical component of an increment is the working software or product feature that meets the definition of done. This means the software is complete, tested, and potentially shippable. Documentation. Any necessary documentation to support the increment, such as user guides, release notes, or technical documentation, should be included if it adds value to the end user or stakeholders. Test results. The increment should be validated through testing. This includes unit tests, integration tests, system tests, and acceptance tests to ensure the increment meets the specified acceptance criteria. Configuration and environment setup. If applicable, the increment may include any configuration changes or updates to the development, testing, or production environments required to support the new functionality. Bug fixes and enhancements. In some cases, an increment may include fixes for existing issues or enhancements to previously delivered features, as long as they meet the definition of DoD and contribute to the overall progress of the project. Updated backlog. The product backlog is typically updated to reflect the completed increment. This may involve adjusting priorities, refining remaining items, or adding new insights gained during the increment's development. Feedback and learnings. Insights gained from user feedback, retrospectives, or reviews during the increment are documented and used to improve future increments. Each increment is designed to be a building block toward the final product, delivering value incrementally and allowing for continuous feedback and adaptation throughout the Agile process. Wrap up. An increment is a functional, tested, and usable piece of software, forming a crucial building block toward the product goal. This approach delivers continuous value, enables immediate stakeholder feedback, reduces project risk, and ensures tangible, measurable progress at the end of every iteration. Agile Project Key Performance Indicators, KPIs. Agile Key Performance Indicators are metrics used to measure the health, efficiency, and success of Agile projects. These KPIs help Agile teams, Scrum Masters, and stakeholders understand how well the team is delivering value, improving over time, and meeting goals. The table has 3 columns. KPI, column 1. Column 2, what the KPI measures. Column 3, KPI contribution. Velocity, amount of work completed per sprint, usually in story points. Tracks how much a team can deliver and helps in sprint planning. Sprint burndown, remaining work versus time during a sprint. Shows if the team is on track to complete sprint goals. Epic and release burndown, progress toward completing larger bodies of work. Helps track progress over longer timelines than a sprint. Lead time, time from ticket creation to delivery. Shorter lead time equals faster value delivery. Cycle time, time from when work starts to when it finishes. indicates team efficiency and helps identify bottlenecks. Team happiness, satisfaction. Survey-based metric of team morale. A happy team is more productive and sustainable. Cumulative flow diagram, CFD. Visual of work in different stages. To do, in progress, done. Helps identify bottlenecks and workflow issues. Escape defects. Bugs or errors found after release. Indicates quality of testing and development. Deployment frequency. How often new code is deployed to production. Frequent deployments amount to more agility and quicker feedback. Customer satisfaction, CSAT or NPS. Customer feedback on deliverables. Measures how much value is delivered. Wrap up. Each KPI will be unpacked in additional videos. Agile Project Velocity. A velocity chart in Agile is a simple, powerful tool that helps teams visualize how much work is completed over a number of sprints. It's primarily used in Scrum, but also applies to other Agile methodologies that use time-boxed iterations. A velocity chart displays sprints on the x-axis, time, story points or effort units on the y-axis. For each sprint, it typically shows 2 bars. Planned velocity, total story points committed to at the start of the sprint. Actual velocity, story points completed by the end of the sprint. The table shows sprints 1 to 4, what is committed and what was actually planned. A burn down chart represents the ideal burn down line, which is the blue line. The actual burn down line is the green line. Then there's remaining work and time, shown on the different axes. The scope is fixed, shows remaining work. A burn down chart in an Agile project visually represents the progress of work over time. Its main components include the x-axis, time. The axis typically represents the time duration of the sprint or project. It could be divided into days, weeks, or other relevant time intervals. Y-axis, work remaining. This axis represents the amount of work remaining. This can be measured in story points, hours, tasks, or any other unit used to estimate work. Ideal burn down line, a straight line that slopes downward from the total amount of work at the start of the sprint to 0 at the sprint's end. It represents the ideal pace of work completion. Actual burn down line, a line that shows the actual amount of work remaining over time. This line fluctuates based on the team's progress and reflects the reality of work completed. Completed work. The points where the actual burn down line drops indicate work that has been completed. This helps visualize progress toward the sprint goal. Sprint goal or milestone marker. Some burn down charts include markers to indicate specific goals, milestones or sprint boundaries, helping to contextualize progress, anomalies or deviations. Any significant deviations from the ideal burn down line, such as sudden increases or plateaus, can indicate issues like scope changes, underestimated work, or blockers. These components help track progress, identify potential risks or issues early, and adjust efforts to ensure the timely delivery of work. Burn up chart. The blue line is the baseline, the green line is actual work, slows upward, you have a time and work units. Scope may change, shows progress and scope. A burn-up chart is a project management tool used to track work completed versus the total amount of work over time. It's often used in Agile and Scrum methodologies to visualize progress toward a goal. The key components of a burn-up chart include the x-axis, horizontal axis, which is time, usually represents time such as iterations, sprints, days, weeks, shows the timeline of the project. Y-axis, vertical axis. Work units. Represents the amount of work typically in story points, hours, tasks, number of features. Total work line or scope line. A horizontal or sloped line showing the total scope of the project. May change over time if scope is added or removed. In Agile, scope creep or adjustment. Shows the goal to be reached. Completed work line or progress line. A rising line that shows how much work has been completed at each point in time. Should trend upward toward the total work line. Optional, forecast, trend line. A projection of when the total work might be completed based on current velocity. Useful for predicting project completion. Optional, scope change indicators, markers or adjustments to the scope line to indicate when scope has increased or decreased. The table is a summary of the components of a burn-up chart. Column 1, component. Column 2, description. X-axis, time. Time intervals, days, sprints, weeks. Y-axis, work units. Units of work. Story points, tasks, hours. Total work line shows total scope or goal. Completed work line shows progress toward the goal. Forecast line, optional prediction of completion date. Scope changes, optional adjustments if the scope increases or decreases. A visual comparison of the burn down chart and burn up chart. Column 1, feature. Column 2, burn down chart. Column 3, burn up chart. Focus, work remaining, work completed. Line movement is down, up for work completed. Scope changes are not easily visible. Epic burn down chart. What it shows. Progress toward completing all the stories within a single epic. Tracks how much work remains in the epic over time, usually per sprint. How's it structured? X-axis equals time, sprints or dates. Y-axis equals total effort remaining, story points or issues. Why it's useful. Helps track if the epic is on schedule. Shows if scope is creeping when new stories are added mid-epic. Useful for product owners and stakeholders to understand progress on big features. Release burn down chart shows progress toward completing all work planned for a release. Includes multiple epics or stories from across the backlog. The structure, X-axis, sprints or calendar time leading up to release. Y-axis, remaining work, story points, tasks or issues. Usefulness, forecasts whether work is on track to meet the release date. Identifies if too much work remains for the time left. Encourages conversation around scope cuts, team velocity or release date changes. The chart shows epic and release burn down. Column 1, sprint. Column 2, work remaining, story points. Column 1 runs from sprint 1 to sprint 7. Column 2 runs from 120 work remaining or story points to 0, which would then be the release or epic complete. Visually, this is a downward sloping line burned down towards 0. Tips. Keep the stories well sized and estimated for accurate charts. Watch for scope creep. Adding work increases total effort. Use alongside velocity trends for better forecasting. Wrap up. Project velocity acts as a retrospective metric that measures the amount of work, story points completed per sprint, enabling accurate forecasting of release dates, realistic sprint planning and sustainable team pacing. This aids to understand capacity, identify bottlenecks and align stakeholder expectations. Agile project, lead time and cycle time. In an Agile project, lead time refers to the total time it takes for a work item, task, feature, user story, etc. to move from the moment it is requested or added to the backlog to the moment it is completed and delivered. Definition of lead time in Agile. Lead time equals completion date minus request date. For example, if a stakeholder requests a new feature on August the 1st and the team delivers it on August the 10th, the lead time is 9 days. Lead time is important. Customer satisfaction, shorter lead times equal faster delivery. Bottleneck detection, long lead times may reveal inefficiencies. Forecasting, helps in predicting delivery timelines for future work. Continuous improvement, enables data-driven retrospectives. Reduce lead time by prioritize work effectively in the backlog. Limit work in progress using Kanban practices. Improve collaboration between roles, for example, dev, QA, and product. Automate testing and deployment pipelines. Break large items into smaller, chippable chunks. In an Agile project, cycle time refers to the amount of time it takes to complete a work item once a team starts actively working on it. Definition of cycle time of Agile is completion date minus start work date. For example, if a team starts development on a story on August the 3rd and finishes it on August the 8th, the cycle time is 5 days. Why cycle time matters in Agile. Efficiency tracking measures how fast the team delivers once they start. Bottleneck identification. Long cycle times may indicate problems in the workflow. For example, too much work in progress, slow testing. Predictability helps forecast how long similar tasks might take. Continuous improvement, useful for sprint retrospectives and process refinement. The ways to reduce cycle time are limit work in progress, WIP, too many tasks at once, slow everything down. Automate repetitive work. CI, CD, testing, code reviews. Improve cross-functional collaboration, for example, involving QA earlier. Ensure clear definitions of done, less back and forth. Break down large tasks into smaller ones. Smaller items move faster. Lead time versus cycle time. Important distinction. Column 1, metric. Column 2, start point. Column 3, end point. Column 4, focus. Lead time, when the task is requested. When the task is delivered. Customer-centric, request to delivery. Cycle time, when work actually begins. When the task is delivered. Team-centric, work start to finish. Cycle time focuses on the execution phase, while lead time includes a waiting time before work begins. Example in practice. An Agile board has the following columns: backlog, to do, in progress, code review, done. A story moves from to do, done in 4 days. That 4 days equals cycle time. The work was being actively executed. If that same story sat in the backlog for 5 days before it was picked up, then the lead time would be 9 days. Wrap up. Lead time measures customer experience. Cycle time measures team efficiency. Reduce both to be more agile. Agile project, team happiness. Measuring team happiness in an Agile project is crucial for maintaining sustainable productivity, collaboration, and morale. While Agile frameworks like Scrum emphasize individuals and interactions over processes and tools, specific methods for measuring happiness are prescribed. Many teams adopt lightweight, regular methods to do so. Measuring team happiness helps to detect burnout or frustration early, build a healthy team culture, identify blockers unrelated to technical work, for example, stress, communication issues, support continuous improvement via retrospectives. Team happiness is measured by happiness index, or the team mood survey. A simpler regular pulse check, often in retrospectives. Example prompt: on a scale of 1 to 5, how happy are you at work this week? Then follow up with, why did you choose that number? This provides both quantitative, that is the score, and qualitative, that is the explanation data. This can be run anonymously, publicly using dot voting or sticky notes, visually with emojis or colored cards. Team health checks, or the Spotify model. Use dimensions such as teamwork, technical quality, mission clarity, value delivery, fun and energy levels. Each team member ranks each item as red, needs improvement, yellow, could be better, green, we're good. Held monthly or quarterly, this method shows trends over time. Retrospectives include dedicated discussion points like, what energized you this sprint? What drained you? How's our team spirit? Daily stand-up mood tracker. Quick check-in. One-word check-in. How are you feeling today? Over time, trends can indicate how morale fluctuates during sprints or releases. These tools provide recurring prompts and dashboards to track sentiment and generate reports. The table is an example of dashboard metrics. Column 1, metric. Column 2, how to measure. Column 3, frequency. Happiness index, measured on a 1 to 5 scale, every sprint. Team health indicators, red, yellow, green rankings, monthly. Burnout signals, engagement and qualitative feedback, monthly. Mood trend over time, daily emoji check-ins, daily, weekly. Tips for actionable use. Don't just measure, act on the data. Protect anonymity, but foster trust for open dialogue. Make it lightweight, not a burden. Use results to guide team experiments. For example, adjust work in progress limits, rotate responsibilities, give time for learning. Wrap up. Team happiness directly correlates to higher productivity, increased innovation, lower turnover, and better product quality. Agile Project Cumulative Flow Diagram. A cumulative flow diagram, CFD, is a key visualization tool in Agile, particularly in Kanban and Scrum, used to track work progress over time and identify bottlenecks. The main components of a CFD include time on the x-axis, represents the progression of time, for example, days, weeks, sprints. Shows how work evolves over that period. Work items on the y-axis. This represents the number of work items, for example, stories, tasks, features. Tracks the cumulative count of items in each workflow state. Workflow states, colored bands or areas. Each color band or shaded area represents a stage in the workflow such as backlog, to-do, in progress, in review, done. These are stacked cumulatively with the height of each band showing how many items are in that stage at a given time. Cumulative nature. The diagram is never decreasing because once an item moves to a later stage, for example done, it stays counted in that stage. The total number of items increases or remains the same over time. Work in progress. Represented by the vertical distance between two stages, for example between to do and done, helps assess how much work is actively being worked on. Throughput. The rate at which items are completed over time, indicated by the slope of the top line, typically the done line. Cycle time, lead time. The horizontal distance between when an item enters the workflow, for example to do, and when it is completed, done, can be inferred by analyzing individual item flow or by using tracking overlays. Here is a summary. Column 1, component. Column 2, description. X-axis, time. Y-axis, cumulative count of work items. Workflow states, colored areas showing items in each stage, work in progress, vertical distance between stages, throughput, slope of the done area, cycle, lead time, horizontal span between entering and exiting workflow. Wrap up. Cumulative flow diagram is a vital tool for identifying bottlenecks, widening bands, measuring cycle time and tracking workflow stability. Agile Project Escape Defect. In Agile, escape defects are errors or issues that were not caught during development or testing and were found after release, typically by end users or in production. Tracking escape defects is important for improving quality and understanding gaps in the development or QA process. Components of escape defects in Agile. When analyzing or managing escape defects, the following components are typically considered: defect ID, description, a unique identifier, and a detailed description of the defect. Helps track and reference the issue clearly. Severity indicates the impact of the defect on the user or system. Common levels: critical, major, minor, trivial. Helps prioritize resolution and root cause analysis. Priority reflects how urgently the defect needs to be fixed. May differ from severity based on business needs or release schedules. Discovery phase, source, indicates when and where the defect was discovered. In production, by a customer during UAT, user acceptance testing. Useful for understanding at what point the issue escaped the team. Root cause, analysis of why the defect occurred and how it escaped detection. Examples: missed test coverage, ambiguous requirements, code regression. Injected phase, when the defect was introduced in the process, during design, development, integration, etc. Helps pinpoint process gaps. Escape point detection gap, indicates how far the defect traveled before detection. Used to evaluate the effectiveness of QA and development practices. Resolution time, time taken from discovery to fix, can influence user experience and team velocity. Impact area, affected functionality, where in the application the defect appeared. Helps team identify risk-prone modules or code areas. Preventive actions, actions taken to avoid similar escape defects in the future. Improved test coverage, better code reviews, process improvement. The summary chart has two columns: component in column 1 and description in column 2. Defect ID, description, unique ID and summary of the defect. Severity, impact level on users, system. Priority, urgency of the fix. Discovery phase, where, when it was found, for example, production or UAT. Root cause, underlying reason for the defect. Injected phase, phase in which defect was introduced. Escape point, where it should have been caught. Resolution time, time taken to fix after discovery. Impact area, functionality or module affected. Preventative actions, steps to prevent recurrence. Wrap up. Tracking escape defects helps Agile teams improve QA processes, enhance automated testing, strengthen definition of done, maintain customer trust and product quality. Agile Project Deployment Frequency. Deployment frequency is a key DevOps and Agile performance metric that measures how often new code is deployed to production or a staging environment. It reflects the team's ability to deliver software changes reliably and quickly. Components of deployment frequency are deployment count, the number of deployments made within a specific time frame, for example, per day, week, sprint. Can include production deployments, staging, pre-production deployments, hotfixes, or patches. Time interval, the time window over which deployments are measured, daily, weekly, bi-weekly, sprint, monthly, etc. Important for consistency and comparison over time. Environment type, where the deployment occurs. Production, real users are impacted. Staging, UAT, pre-release testing environments. Helps differentiate between test and live deployment activity. Deployment method, describes how deployments are performed. Manual deployments, CI/CD pipelines, that is automated. Blue, green or canary releases, impact speed, reliability and risks of deployments. Scope of deployment, what is being deployed? Full application releases, microservices, patches or hotfixes. Influences how frequent and complex deployments are. Team service level granularity. Deployment frequency can be measured at different levels. By team, by project, by service. For example, in microservices architecture. Useful for identifying high-performing or struggling teams' services. Change type. Tracks the nature of the deployed changes. Features, bug fixes, security patches. Helps understand what types of work are frequently being delivered. Lead time to deployment. Optional and related. Time from code commit to successful deployment. It's not a direct component, often analyzed alongside deployment frequency to assess flow efficiency. The table shows column 1, component, column 2, description. Deployment count, number of deployments within a time frame. Time interval, period over which frequency is measured. Environment type, production versus non-production environments. Deployment method, manual, automated, canary, etc. Scope of deployment, what was deployed, full app, microservice, hotfix, etc. Team service granularity, where deployment frequency is being measured. Change type, features, fixes, patches. Lead time to deployment, time from commit to deployment, related metric. Wrap up. Indicates team agility and delivery speed. One of the DORA metrics used to measure DevOps performance. Higher frequency typically correlates with smaller, safer changes, faster feedback loops, reduced deployment risk. Agile Project, Customer Satisfaction, CSAT. Customer satisfaction, CSAT, is a key metric that measures how satisfied customers or stakeholders are with the product, delivery, or team performance. While CSAT originates from customer service and product feedback disciplines, it's increasingly used in Agile to gauge the success of product increments, releases, or even sprints. The components of CSAT are survey question, typically a single standardized question. How satisfied are you with the latest release, sprint, product increment? Likert scale is usually used, for example 1 to 5 or 1 to 10. The response scale defines how users or stakeholders score their satisfaction. Common scales 1 to 5, very unsatisfied to very satisfied. 1 to 10, worst to best experience. The format should be consistent to track trends over time. Respondent group. The following are surveyed: end users, internal stakeholders, product owner, business team, external customers, Agile team members for internal process feedback. Targeting the right group affects the relevance of CSAT data. Timing, frequency. The survey is sent after a sprint review or demo, after a release or deployment, quarterly for product satisfaction. Timing influences response rates and accuracy. Delivery method. The survey is conducted using digital form, email, in-app prompt, survey tool, embedded in retrospectives or sprint reviews. Manual interviews, less common but insightful. CSAT score calculation, formula. Number of satisfied customers divided by total number of responses times 100, which will equal then the CSAT percentage. Typically, scores of 4 or 5 on a 5-point scale are considered positive. The results are in a percentage score between 0 and 100%. qualitative feedback, which is optional and valuable. Open text comments explaining the score. Provide context and actionable insights behind satisfaction or dissatisfaction. Trend over time. CSAT is tracked over multiple sprints or releases. Trends indicate whether satisfaction is improving, declining, or remaining stable. Action plan, feedback loop. Teams should use CSAT results to improve product features, adjust team processes, address stakeholder concerns. Ties directly into continuous improvement. The table summarizes column 1 component, column 2 description. Survey question, standard satisfaction question, 1 to 5 or 1 to 10 scale. Response scale, the scoring method, Likert scale. Respondent group, who gives feedback, users, stakeholders, team. Timing, frequency, when the survey is conducted. Delivery method, how responses are collected. CSAT score calculation, formula to compute the satisfaction percentage. Qualitative feedback, open-ended responses for context. Trend over time, historical view of satisfaction across iterations. Action plan, how feedback is used for continuous improvement. Wrap up. Encourages customer-centric development, provides early feedback on deliveries, enhances stakeholder engagement, feeds directly into Agile retrospectives and product backlog refinement. Agile project principles and steps for Agile project composition. Achieving the right mix in the composition of an Agile project is about balancing people, skills, structure, and ways of working so the team can deliver value continuously. There's no single formula, but there are proven principles and practical steps. Below is a clear, structured way to think about it. Start with the product and value stream. Before forming the team, be clear on product vision and goals, customer outcomes to achieve, end-to-end value stream from idea to delivery. The team composition should mirror the work, not the organizational chart. Build a cross-functional team. Agile teams should be self-sufficient, able to deliver working increments without handoffs. Typical skill mix includes product ownership, prioritization, customer voice, engineering, developers with complementary skills, quality testing, built-in quality, not after the fact, UX design, usability and customer experience, DevOps, platform skills, deployment, automation. Rule of thumb, if a team regularly waits on another team, the composition is wrong. Balance specialists and generalists. The best Agile teams are T-shaped, deep expertise in one area, working knowledge across others. This allows shared ownership, less bottleneck risk, better collaboration. Avoid too many narrow specialists, one Euro expert everyone depends on. Right size the team. Recommended size, that is 5 to 9 people, small enough to communicate, large enough to deliver. Why does this work? Fewer communication paths, faster decisions, stronger accountability. If the scope is large, split into multiple small teams. Align them through a shared vision and lightweight coordination. For example, Scrum of Scrums. Clearly defined roles without silos. Common Agile roles. Product owner, value maximization and backlog clarity. Scrum Master, Agile coach, flow, improvement and team health. Development team, collective responsibility for delivery. Key mindset. Roles clarify accountability, not job titles. Everyone contributes beyond their label. Ensure strong team dynamics. Composition isn't just skills, it's how people work together. Look for psychological safety, willingness to collaborate, openness to feedback, shared ownership of outcomes, Invest in team working agreements, regular retrospectives, continuous improvement culture. Provide the right level of support, not control. Agile teams thrive with clear goals, stable membership, empowerment to make decisions. Avoid constant resource swapping, micromanagement, overloading the team with dependencies. Leadership role, that is to enable, remove obstacles and trust the team. Inspect and adapt the composition. The right mix changes over time. Regularly ask, are we blocked by missing skills? Is workload balanced? Are hands-offs slowing us down? Is team morale high? Then, add or shift skills. Adjust team boundaries. Coach rather than restructure too fast. Wrap up. The correct composition of an Agile project is a small, stable, cross-functional, empowered team aligned to a clear product goal and continuously adapting how it works. Wrap up of the project management Agile approach. Applying the Agile approach to product development may not exactly replicate the theory. It does, however, provide a sound reference point for Agile practitioners to stay on track.